This is Erin Cavazos. I'm a senior engineer with the San Antonio River Authority, and I'm talking about the San Antonio area floodplain mapping update. I wanted to give a little background before diving in to give the context of who we are and why we do floodplain mapping. We were created by the state legislature in 1937, and ultimately the purpose was to plan, manage, and implement water-related programs and projects. And we do this generally within the San Antonio River Basin, but our jurisdiction includes Bexar, Wilson, Karnes, and Goliad counties. My presentation focuses on activities in Bexar County, and you can see how Bexar County is divided into several watersheds. Our floodplain mapping program is one way we act on our commitment to safe, clean, and enjoyable creeks and rivers. This is kind of a nutshell history of flooding in Bexar County. The two most destructive floods in recent memory were in 1998 and 2002. In 1998, there were, around 30 inches fell in 2 days, resulting in 32 fatalities and $500 million in damages. Then in 2002, around 35 inches fell over 8 days, resulting in 12 fatalities and nearly $1 billion in damages. And that was damage to approximately 48,000 homes. So those two events sparked the formation of Bexar Regional Watershed Management. The managing partners of this group are San Antonio River Authority, the City of San Antonio, and Bexar County. And then 20 suburban cities also participate. And you can see the goals of the organization listed here, but they're just basically to address flooding and water quality concerns across jurisdictional boundaries within Bexar County. Each of the managing partners has a specific role, and the river authorities one of ours is floodplain mapping. Embracing that role, we became cooperating technical partners with FEMA in 2003, and we're currently participating in the risk mapping assessment and planning program, which is where we undertake large-scale floodplain mapping updates and produce other flood risk data. And we also participate in the LOMAR Review Partner Program, which is how we keep up with all the changes to the maps. So back in the day, we did the digital flood insurance rate map conversion from paper maps, and they began that study, because this is before my time, but they began that study in 2005. And when they did that, they established some regional modeling standards. They developed these georeferenced models, which I can't even imagine working with ungeoreferenced models everywhere. The mapping went digital instead of paper. They did improvements in data, such as using 2-foot contours rather than 5-foot contours, or some of the stuff was even developed on the 10-foot USGS contour maps. And I made a note here that the hydrology was done with HEC HMS 2.2.2 and 3.1.0, depending on which watershed you're looking at. And these were improvements over HEC 1. They are georeferenced and all of that, but there's still some clunkiness in those. So just to say that the 2010 DFIRM was a big step. And it gave us a lot that we're starting with now, so we're not really starting from scratch. Since these maps went effective, we've had a few changes. We're approaching our 300th case in our review program, and you can just see all the red outlines of LOMAR boundaries. Some of these streams are so patched, like you don't even know where to start with which one is most recent. I mean, they have dates, so you can figure it out, but it's a puzzle. And it's really kind of you can see that there's a need to start fresh. The other thing you can kind of tell is that there's a lot of development going in the areas outside of Loop 1604 primarily. And I've outlined the biggest growth areas in these orange polygons. Of course, we have a state natural area right here, and that's not included. I did manage to clip out Camp Olis. So yeah, we're seeing a lot of development, and we have these pictures show the orange areas is where like specific construction has happened since 2005. 2005 is when they did the land use data that was used in the 2010 FEMA. So between 2005 and 2019, when we commissioned a new land use shapefile, you can see all the changes in these two select areas, and those fall within the orange boundaries from the previous slide. So we were starting to think about the need to update the hydrology, particularly in these watersheds with the development changes. But we were also thinking about kind of the future of flood risk analysis with FEMA and what they're considering, the directions they're taking, that maybe we should look at changing our modeling platform into something a little more distributed. And so we looked into the gridded surface subsurface hydrologic analysis model, and thinking it might be a good potential for hydrology, flood prediction, water quality, you know, just everything, just one model, do it all. But it wasn't quite the one size fits all solution we were hoping for. We also looked at going all 2D HEC-RAS, but for much of our area, we don't necessarily need 2D modeling. We have some streams, you know, it just goes right down in the stream, just like you think it should. So we didn't take that leap. Maybe someday, if these two models get married, we could use that sort of thing, but we're just kind of keeping our eye on that. I bring this up though, because when we were testing Geisha, the gridded surface subsurface hydrologic analysis model, we kind of started using green and amped for the loss method for the gridded data. And we observed something in the Surgo data. Well, it was more kind of in our analysis, we started observing some things. So this is the Surgo data with the dominant hydrologic soil group displayed. And this is what we're using for the curve number in our hydraulic models right now. And you can see, you know, that it goes from A with the highest infiltration capacity to D with the lowest, and there's a lot of D everywhere. So that's fine, that's not interesting. But what is a little odd to me, or I don't really understand, is when I put the Edwards Aquifer recharge zone on there, it's all D. And I don't think, I mean, it's the recharge zone, so we know there's infiltration. The dams out there don't hold water longer than, it can be completely full and then completely empty within 2 days. So the water's going in, but this data doesn't show any of that. So when we looked at the soil texture class that we have, that it's what we use to develop the green and amp parameters, there are a lot more categories, and you can start to see the diversity in the soil types. And so when I did the colors on this map, I tried to match, you know, clay to the D, the same black color, and you can see that there's not as much. And bedrock also, I used the D color, there's just not as much. And then anything that was clay with a mix of some other sand or loam or any variation of that, I put in gray, but I ran out of gray, so I had to start using brown. And then the kind of sand dominant ones with a mix of other things are in the green, and then pure sand is blue, just like the type A. So there's just a lot more variety in the soil texture class than in the hydrologic soil group, and it gives us the chance to kind of differentiate the characteristics of the different soils, like between the recharge zone and the confined zone of the aquifer. It's kind of a big leap to change the loss method between what we're used to and what has been used for a long time. One of the things we're relying on to help us make that transition is a network of pressure transducers that have been collecting depth time series data at all of these points across Bexar County and the city of San Antonio at their low water crossings. So we're trying to pull in extra data to help us with the calibration so we can build the confidence in the new parameters and the new loss method we plan to use. So that brings us to what came next. So we're in the midst of planning all of these updates to the hydrology based on which watersheds are impacted by development. We'd already started some studies, and then Atlas 14, the draft was released in the middle of some of our planning. And in our case, the 100-year rainfall that we used for the whole county was 10 inches. It was a pretty, this is the old data, and it was pretty much across the county. You could just average it 10 inches. Now we're going from a range of 11 inches to not quite 13 inches, but up here it's pretty darn close. I know Houston's over there saying Crimea River, that's not that big a deal, but it's a different situation than what we were used to, and didn't feel like we could just average it across the whole county anymore. The range was too much to try to average. So Jacob Powell with the city of San Antonio led a stakeholder process to come up with how to simplify that spatial variation without oversimplifying it, and put it in a form that the city of San Antonio and Bexar County could regulate to for their design criteria, and we could use for modeling. And that resulted in these 5 precipitation areas with the interval between each precipitation area in the 1/4 to like 1/2 inch range. So if you're working on something that's bounding 2 different, or it's intersecting 2 different precipitation areas, it's not a giant leap. So that's how we approached implementing it, but then we really had to take stock of where we were with our studies and our plant studies and our ongoing studies. The first one we dealt with was our Cavazos watershed. It was already on the maps were, or the floodplain mapping was being delivered to FEMA. It was kind of at a point of no return. So we just proceeded without Atlas 14, and it's on the list of things we're just going to check the revised precipitation and see how much that impacts the floodplain mapping, and if it's significant impact, we will come back and program updates to that watershed after we get through some of our other studies. The others that we had already ongoing were the upper and mid Cibolo watershed, and that included hydrology all the way through the whole, like the lower Cibolo as well. And then some Medina tribs that we had started studying a while back. And those were at a point where we could incorporate Atlas 14 data without significantly impacting the budget. And they were at a point also where it would cause the project to be delayed, but it was still better than just proceeding without taking this into account. So we incorporated Atlas 14 into those studies, just extending the schedules. The Leon and Salado watersheds were the ones we were targeting for updates at the time Atlas 14 came out. So because of the development occurring in those watersheds. So we were able to just roll Atlas 14 in and pretend like we had planned it that way. And those are moving along relatively smoothly. Upper San Antonio, which is where downtown San Antonio is, and the Riverwalk and all that, wasn't on the list to be updated because the development isn't changing. But of course, we want to see the impacts of Atlas 14 there. So we were able to work with FEMA to get funding for that study last September, and some of the initial steps have already been completed. The hydrology was started last month, and we plan to start hydraulics this coming month. August or early September. And finally, we have the Lower Medina and Lower Cibolo study areas, which we are working with FEMA to fund starting in September. And that would just cover survey, hydraulics, floodplain mapping, and flood risk products, because the hydrology is already studied in other studies. And let me just catch up on my bullets. I didn't realize they were all hiding. So yeah, the Leon Salado scoped with Atlas 14. Upper San Antonio is now being studied due to Atlas 14. It's just on a later schedule, along with Lower Medina and Lower Cibolo, which will be funded this fall. I mentioned that we're doing flood risk products in all our studies. These will be used to reassess our areas of high flood risk, because we do our watershed master planning. We will make some of the depth and percent chance grids available on a web map application. And one thing, well, we plan to keep these flood risk products updated in coordination with the LILMAR review and approval process. This is a new development since DFIRM. We were doing the flood risk products based off of the original DFIRM models, but then we weren't able to keep up with WOMARs or anything over that whole period. But now that we'll be able to start from the beginning with the flood risk products, and as we get LOMARs, we'll be able to kind of patch in the new flood risk data and keep those up to date and kind of in, consistent with the revised floodplain maps. So as far as where we are in these studies, the Medina, Leon Salado, and Cibolo hydrology are all in the review and address comments stage of the task, hoping to have those completed by, say, October. Many of the hydraulics models have been developed, kind of up to the point of needing flows, and we're looking at maybe this time next year having draft floodplains being reviewed and possibly starting to roll those out on a website for public review. And we'll start engaging, as we get closer to that, we'll be engaging our communications team to plan the rollout and how we're going to do the open houses and those things that work with floodplain mapping updates. Upper San Antonio, like the hydrology is probably coming out a bit later than October because it just started. But then we're hoping that hydraulics and the floodplain mapping will sync up with the other studies to be released next summer. Lower Medina and Lower Cibolo, we'll be starting in the fall. They'll be behind and on their own schedules. If the stars align, we may have one single preliminary phase for all of these studies, but it's more than likely going to be split into two, and maybe the lower ones will be synced up with some of our lower basin studies. So then after all that happens, I'm taking a big vacation and look forward to the discussion later with the others on the panel. Thank you very much.